finally. Okay, so the first question that we have here, this was a problem set from last year. So may ibang set ng problem set from last semester. But unfortunately, I cannot find the copy of it as of today. Okay, so describe the illusion problem. Ano yung illusion problem natin? If you recall. I want us to have an open discussion. So ano yun usually illusion problem natin?
Actually, hindi. Plans pa po siya, ma'am. Hindi pa po siya, parang titingnan ko pa po next semester. Ano po mangyayari.
So ano yung tinatawag nating illusion problem? The so-called general illusion problem. So usually it pertains doon sa effect ng separation with the so-called retention time. So if the retention time is, we could say, fast, okay? So usually, hindi siya nasa-separate. Tapos kapag very slow naman, nandun yung tinatawag nating separation. Okay? So, it happens when chromatograms are obtained so sample that contains species with widely different partition rates or partition ratio. So when the conditions are such that the good separations of the more strongly held species is observed, conversely when the conditions are chosen, they give satisfactory separation. So how do we solve the general illusion problem in LC and in GC? Paano natin nasusolve to?
Change in temperature of the column, sir.
Saan yung change in temp?
In LC pa.
Okay. So what we do is we have the so-called temperature gradient. So that means with time, we might make it like ganyan, tapos tataas, tapos ganyan, tapos tataas uli, tapos. So this is the temp and this is the time. So in GC, usually we use what? Temperature gradient. And the separation is much better. Okay, because ang nangyayari lang kasi dito yung iba, strongly bound siya. So ang nangyayari, you have to separate them based on the difference of their boiling point for GC. Now, how about for LC? How do we separate them? How do we solve the general illusion? How do we solve the general illusion problem? We use the gradient condition. Okay, so when we say gradient, you have a changing composition of your solvent. So yan yung pag-solve ng tinatawag nating general illusion problem. So ang ano kasi dito, kapag masyadong mataga, I mean, we can separate them at a longer time, that loses the practicality or applicability. So you have to find ways to do the separation. Okay. Now the next question that we have there, why is longitudinal diffusion a more serious problem in GC than in LC? Ano yung longitudinal diffusion? Saan mo siya makikita? Anyone? So, ang ano dito, ang question that is being asked, why is longitudinal diffusion a more serious problem in GC than in LC? So, the first question that you asked, where does the term longitudinal diffusion comes in when we talk about chromatography? Saan siya lumabas? No, specifically, saan equation siya lumabas? Okay, doon siya lumabas sa Van-Dimter plot. Now, specifically, ano siya sa Van-Dimter plot? Van-Dimter plot or equation. Siya yun, B. So how do we write Van-Dimter plot? Anyone? It is what? H is equals to A plus BU, B divided by U plus CU. Okay? So usually, ang sa Van-Dimter plot na to, ang longitudinal diffusion is the term B. Right? Now yung C, ano yung tinitake consideration doon sa C?
Mass po.
Okay, yung mass transfer between the mobile phase and the what we call stationary phase. Okay, now the question that we have is, bakit mas apektado sa GC ang longitudinal diffusion kaysa doon sa tinatawag nating LC? So what do we take into consideration? So we're talking about gas or gases versus the liquids. So ano masasabi natin doon sa diffusion coefficient ng gas? Nagdi-diffuse ba ang liquid? If you remember your Gen Chem, you have one gas law there that refers to the diffusion of the gas. Right? So in that case, we could say that gas diffuses compared to the what we call the liquid, and the diffusion coefficients of these gases are usually what? 1,000 times greater than those of the liquids. So in that case, the longitudinal diffusion occurs much faster, okay, in GC than in LC. So ano ang proof nito sa chromatogram? Ano yung problem ng longitudinal diffusion? Anyone? Usually it causes what? Band broadening. So if you're going to look at a GC peak compared to what we call an LC peak, what can you say? Alin yung sharp yung peak? Alin yung sharper? Okay? Mas sharper yung peak ng tinatawag nating LC ba? Ang mas sharper? Nakakita na ba kayo ng GC chromatogram? Versus LC chromatogram? I'm trying to find out. So I could show you the difference between them. So usually, if you have a GC chromatogram, their peaks are sharper compared to what we call an LC chromatogram. And the reason for that is because of that longitudinal diffusion. So ang practical ano dito is you don't have the band broadening that you usually observe doon sa LC. Okay? So mas maganda yung peak ng GC in terms of what we call the sharpness compared to what we call HPLC. Yun yung parang ano dito, story. Okay? Why longitude is a more serious problem? Kasi nga, masyadong ano yung diffusion ng gas. Okay? And that is also the advantage of the supercritical fluid chromatography compared to LC and GC. Mas ano din yung diffusion rate nila. Okay? So the next one. How does salinization decreases tailing of chromatographic peaks? Are you familiar with salinization? Is this the first time for you to hear the process of salinization? So yung term na tinatawag na salinization, okay, parang kinakap lang niya yung surface. So usually kapag may surface ka, usually sa ano mo, sa stationary phase, you have what? Hydroxyl group. So what is hydroxyl group? Okay, OH minor, OH. So what's the problem if you have an OH in your surface? Anong problema nung salinization ng ano kapag meron kang OH? It can interact with your sample. So what they do is they do some end capping. So when they do end capping, okay, what happened is kinakap nila yung hydroxyl group mo. Okay? So ang inaano nila dito ay yung tinatawag nating silane. So example of what we call salinization, I'm going to share to you this one. Okay. So usually when they have a salinization, they cover the hydroxyl group. Okay, so it caps the hydroxyl group to which it can be a site of interaction. So kapag wala ng hydroxyl group, wala na yung interaction na yun. So usually they use what we call silane. Kaya ang tawag sa kanya is salinization. I don't know if you have heard this term before. Ano yung compound na involved sa salinization?
Silicon po.
Okay, so usually it is the silicon. Some of the salinization they happen in situ, some of them they happen what we call with time. So the problem with salinization, yung polar component mo magiging non-polar. I have experience doing salinization and capping. So I use trimethyl chlorotrimethyl silane. Okay. So it makes my solution from a polar to a non-polar when I end cap. But the good thing with the end cap, when I end cap my stationary phase, I use it as binding materials. The binding improves. Okay, because I'm trying to do like a molecular imprinting. So I want the interaction that the target sample that I have is similar to the structure, not the hydrogen bonding that would form when you have a hydroxyl group. So yun yung ano, and they're really using this in chromatography. Okay, so that's what we call what salinization do. So how does it decrease tailing? So yung tailing, usually it's due to the interaction of your samples or components with the stationary phase. Okay, so if you end up the hydroxyl group, that's the hydroxyl group is the one that's doing the tailing. So you might say, ano ba yung tailing na ano? So usually instead na ganito yung ano mo, meron kang na ano na parang ganito. So that means there are some interaction that is happening there. So if you do a salinization, most likely it will be like that because the hydroxyl group that interact with it, okay, is not what we call causing any interaction anymore. Question? Tanong? Hindi ko pala na pinapakita kung ano yung peak. So ito yung tailing na nangyayari. Okay? So how do GLC differs from GSC? Paano magkaiba yung dalawa?
Sir, sa GSC po, it uses a solid adsorbent as a stationary phase. Tapos yung GLC po uses a non-volatile liquid.
So if we're going to look at this, we could say it has something to do sa stationary phase mo. Okay? In a gas liquid component, usually you have what? Maybe a liquid that is immobilized on a solid support. Now, in a GSC, what will happen? The stationary phase is the solid itself. And when they interact, usually paano yung interaction nila? So sa GLC, it will be an interaction within the gaseous and the liquid phase, right? Pero dito, it's mostly the retention of the sample in the gaseous, the retention of the component in the gaseous sample in the stationary phase. So we could say there's more of what? Absorption on this side. And this is more on what? Partition. So I think that's the simplest way of differentiating the two of them. But both of them are under what? GC. Okay. Question. Yung iba. Yung iba. Ano masasay nyo? So the next that we have is selectivity factor. So how do we differentiate or how can selectivity factor be manipulated in gas chromatography and liquid chromatography? Now, the question that we asked, ano yung selectivity factor in the first place? Class, ano yung selectivity factor?
Ability po to distinguish between the components of a
component.
sample.
Yep. So ano yung formula natin doon? Still remember the formula? Ano? Siya ang Panginoon. Tawag dun? The alpha, right? And you have the K. K prime B over K prime A. So anong kailangan natin sa selectivity factor? We want it to be what? The higher, the better? Is there a particular number that we want your selectivity factor to be? Okay, it should be greater than 1. So if you're going to look at the formula of this really alpha is what? K of B over K of A, right? Or paano natin aanuhin to kapag meron tayo ay chromatogram? Retention time of B minus the void volume. Retention time of A minus yung retention time ng void volume natin or T0. Right? So let's say ito yung A, B, tapos ito yung void volume. So as much as possible, we want the selectivity factor, okay, to be at least greater than 1. Now, how are we going to what we call manipulate sa GC, ano yung gagawin natin? Okay? Stationary phase. So, pwedeng i-modify natin yung packing material doon sa stationary phase. Now, how about sa LC? Pwede ba rin natin baguhin yung stationary phase? Okay. So, we can also vary the stationary phase, but in addition to that, you can also manipulate your mobile phase, yung chemical composition ng mobile phase. So, we could say it's easy to manipulate the selectivity factor in LC compared to the GC. Bakit? The mobile phase in GC just serve as what? Ano yung mobile phase sa GC? It's only serve as a carrier. You seldom see an interaction between the sample and the mobile phase. Unlike in the liquid chromatography, there are instances that some of the sample interact with the mobile phase in addition to it interacting with the stationary phase. So at least mas maganda yung pag-separate nila. Pero because of the high diffusion of the GC, mas sharp yung peak nung GC kaysa doon sa LC. Okay? So let's go to the next one. So if we're going to do this thing, sige nga, try nyo nga to for a reverse phase separation. Predict the order of elution. So maybe wala tayong quiz na ganyan, but maybe in the finals we will have some quiz like that one. So alin yung mauuna at alin yung mahuhuli? So what you have here is a reverse phase. So sa reverse phase, ano yung stationary phase? Polar or non-polar? So if we have what we call the RPLC, the reverse HPLC, okay? So usually when you have a reverse, so that means your stationary phase is non-polar. If you have the normal HPLC, the stationary phase is polar. So if your stationary phase is non-polar, the polar elutes first, right? Here, the non-polar elutes first. So we have the sample that we have here, ethyl acetate, diethyl ether, nitrobutane. Tapos yung isang set naman, hexane. Maybe we can do it like 1, 2, 3, 4, 5, 6. And then the other one is hexanol. 1, 2, 3, 4, 5. One, two, three, four, five, 6. And the other one is benzene. Sige nga. So if I'm going to make this A, B, C, A, B, C, so ano yung elution order? Alin yung pinakamabilis, alin yung pinakamabagal? One, two, three, 4, 5, 6. How about the others? Yung iba, no, I can always change it in what we call in the questioning, right? So if it's a reverse, I would say this one will elute first, followed by A, and then B. But if it is normal, it's B, A, and C. Right? Now here in the reverse, yung reverse naman yung tinatanong eh. So if this is in the reverse, which one goes first? So you go with, I think, the B, because that is the what we call most polar. So alin yung more polar between benzene and hexane? Is it A or C, the next one? Okay, so between the two, benzene daw eh. Agree ba kayo? So if you're going to what we call look at it, bakit mas polar yung benzene kaysa sa hexane? Try to look at the polarity sa ano ba tinatawag yun? Polarity index or relative polarity. And you can say there that your benzene is more polar than your hexane. So if you are in doubt, sabi niyo, oh, bakit ganun? Okay? That's the reason why this elute first, because benzene is more polar than A. Mas mababa yung relative polarity ng hexane kaysa sa benzene. Now, you all know why B is the most polar, because you have the alcohol functional group, the hydroxyl group. Now, if it's a normal, babalik na rin nyo lang. So, A, okay, and then followed by C, and then B. So, kaya sumagot ng tanong ng mga ganito? I think they have questions like this in board exam. One of the things that you need to know. Tanong? Now here. So this is going to test your knowledge on the different chromatography that was discussed. Okay? How are you going, or what type of LC will be suitable for the separation of the following. So if you have 2 alcohol, or you have this, what we call, ano ba tawag dito? Carboxylic acid, the COOH. Or you have this so-called benzene ring, PAH, anthracene versus phenanthrene. And then if you have this high molecular weight glucosides, and if you have ion, sige nga. Nanood ba kayo ng video? Size exclusion ba? You only use size exclusion in what? Saan mo gagamitin yung size exclusion dyan? Sa 5 yan. You only use size exclusion in high molecular weight. So if you remember, there are what we call basic chromatography. I mean, in chromatography sa LC, you have what? The partition. Okay. Under dito sa partition, nandun yung reverse phase at normal phase. Tapos meron kang tinatawag na adsorption. Tapos meron kang tinatawag na yung size exclusion. Okay, and then you also have the so-called ion chromatography. At ano pa yung isa? Yung affinity chromatography. Hindi kayo nanonood. So mostly sa mga small molecular weight, you use this one. But it depends on the sample that you have. So usually, when it is polar, so a compound like the first two, you can either use partition, and specifically, you can either use the normal or the reverse phase chromatography. Okay. Now, for the what we call nonpolar substances like the anthracene. So usually one of them is like this, and the other one, I'm not sure. I think the nanthrene is like that one. All of them ring. So what do you think? These are what we call PHS. What is PHS? Polyaromatic hydrocarbons. Okay, so usually if you use PHS, the method that they have there is adsorption. So if we're going to go specifically doon sa tanong, so we could say these first two, it could be partition, okay? The normal phase partition. Now for the third one, you could say it's absorption, okay? Now for the high molecular weight, that could be your ion exchange, the size exclusion thing. Oh no, not high ion exchange, it's just size exclusion. Okay, ang ion exchange is just for the charged particle. So those are the what we call type of liquid chromatography that you can use for this one. And then you are asked here, describe the effect of pressure on the supercritical fluid chromatogram. Anong pwedeng gawin ng pressure? If you increase the pressure, what will happen? Okay, so if you're going to increase the pressure, it's going to cause the density to increase. And what's the effect of that? It's going to change the retention factor of the analytes. Okay, now if you increase the pressure, it increases the density. So what will happen? It's going to reduce the elution time, or in short, it will become faster. And that's the principle that they have in the so-called micro, what we call pressure. So they added increased pressure to make the run faster. It's just you're pushing the liquid at a much faster what we call elution time. Okay. Now, the next one that we have here, the effect of the pH. So how does the pH affect the separation of amino acids by electrophoresis? Ano yung principle ng electrophoresis? Anyone?
Separation of molecules po based on size and charge.
Okay, so it is based on size and charge, but definitely charge. Okay, so what does the pH do? How does amino acid affected by what we call the pH? Amino acids are what we call, are you familiar with the term sweeter ions? Naintindihan niyo ba yung term na sweeter ions? So sweeter ions, it has what? It has the amino group and carboxylic group. So depending on the pH, sometimes they're protonated or deprotonated. So you have two sides there. Okay, and what's the other one? An H, and the other one is the functional group that differs one amino acid from the other. And sometimes this third group that you have there, they contain either another basic or acidic group that further change the pH. I mean, the further what we call change the structure of your amino acids at a given pH. Okay? So depende doon sa pH, magkakaroon ka either ng what? Positive or negative charge. Usually at lower pH, you have a positive charge. At higher pH, you have a negative charge. Okay? And because of this, that's one way for you to separate one amino acid from the other. It's not really one amino acid, but usually proteins. Okay, because capillary electrophoresis, you use it for proteins, and most of the proteins are made up of what? The amino acid. Okay, so depending on the charge, so if you have a positive charge like in low pH, your protein molecules will be attracted to the negative electrode. Okay, and if you have a basic solution, okay, it will be attracted to the positive electrode. And that's the way they do the separation in capillary electrophoresis. Okay, now the next two here, the next question that we have, usually is a simulation one. So I'm not going to go on that, but what we're going to do is this, the last one. So we're going to solve problem. So if you have this chromatographic experiment using a column that is 25 centimeter long with a flow rate of 0.40 ml per minute, So there's two components that will use with retention time of 30 and 50 minutes with the void volume at 5 minutes. So the height widths of the peaks were determined to be 18 and 22 minutes respectively. So determine the resolution. Okay. So how do we write the resolution? That's RS equals to 2 times TRB minus TRA over the width of A plus the width of B. Now, the question, what are those values? So I can go back to the given. So we have there what? A 50 and a 30, and then an 18 and a 22. Right? So I have here a 50 and a 30 divided by an 18 and a 22. So this gives me what value? Anyone? One point zero. Is that what you get? Now, this type of question can come out in your board exam. Maybe you can ask some who took the board exam just to, know if they really what we call come out, or questions like this really come out. That's the only way for you to check. Diba ang mahirap ata na question this year is more on analytical chemistry. So you have to prepare for that what we call type of question. Question. Tanong class. Now let's go on the next one. Retention factor for the two compounds. So what is the formula equals to? Anyone? So retention factor is usually K, right? So K of what? In terms of K of A. So that is retention factor of A times the mobile phase or the void volume. So that is equals to what? 30 minus ano ba yung void volume doon? 5 minutes. Okay. So 30 minus 5 over 5. Now for B, it is 50 minus 5 over 5. So what's the answer that you have? Hello?
For A po 5, for B 9.
So yan yung tinatawag nating retention factor. And if you want to look at the relationship between that one, we're going to get the so-called selectivity factor. So this is just Ka of B over K over A. So this is just 9 over 5, which gives you
1.8 po.
1.8. Now, ito yung challenging. The next one, because most of my students got this wrong last time. The so-called, nasaan na yun? Column length needed to achieve a resolution of 175. So what do we need to solve? We have to solve first for what? Alam niyo yung N? So if you're going to look at this, you are asked to solve for the length of the column needed to achieve a resolution of 175. So the way that you're going to solve this, you have to solve first the so-called N. N of A and N of B. So usually what do you have there? The 16 times the retention time over the area. And then this one 16 also PRB over WB, and you put their squared. And then you have what? 16. So you have this one 30 over, is that 18? And then this is 16, 50 over 22 squared. So ano yung mga values na makukuha nyo? So this one will give you around 44, and this one will give you 82. Now, what are we going to use to get the height? Because this is just the theoretical plate, so we're going to get the average. So anong average niyan? 44 plus 82, that will give me around what? That's a 6. And then a 12. So that will give me around 63. And then from that, I can have the relationship H equals to L over N. So what is the given length? 25 centimeter. And then the N is equals to 63. So that means I have around 0.40. So ano yung resolution ng present ano natin system? Because we are asked what will be the column length to give us a certain resolution. So the present resolution that we have is 1, right? So I can have a ratio and proportion here, RS1 over RS2, and then I put here the theoretical plate. So what do we have? 1 over 175, and then this one square root of what? 63 divided by square root of the one that we're looking for. So what is N2 here? So we have around 193. Should be around 192.94, 193. Now, where are we going to use that 193? So we have this relationship, right? So what do we do? So we need to get the L. So L is just equals to 193 times the theoretical, the height there, that is 0.40. So that is equals to how many centimeter? 77 centimeter. Kaya? Kaya ganitong problem sa exam? Kakayanin. Open notes naman. Yeah, the problem is baka isipin niyo open notes, hindi na kayo mag-aaral or orada kayo gagawa. Gayahin niyo yung mga estudyante ko dito na pag online class. Oh, it's an open note, so we don't need to study. Kaya pagdating sa exam, mga scores mababa pa sa edad ko. So question. Before you utilize the remaining time, kung ano man maano natin doon sa kasunod na module. So question, do you learn anything new na hindi na-cover nung nanonood kayo? So let's try module 4. Kung ano mang umabot hanggang 11 na 12:50 dyan. 11 pa lang kasi sa akin. So this is spectroscopy. And I think here it's more on what? Question than problem. Delilah question. Diba? Why? So the question is, why does a deuterium lamp produce a continuum rather than a line spectrum in the ultraviolet? So saan ginagamit yung deuterium lamp? Anyone? Where do we use deuterium lamp? What instrument do we use deuterium lamp? So pag nagtanong ako, deuterium lamp is used in IR, true or false? Sige nga. Deuterium lamp is used in IR instrument, true or false? How about the others? Si Irvin lang nasagot, sina Shen. So if it's false, where do you use deuterium lamp? Okay. So deuterium lamp, usually you use it in UV. Now, if you look at the deuterium lamp, it is what we call continuous, like this, hindi yung line spectrum. Okay. Now, to answer the question here, you have to look at what a deuterium lamp is, how it works. So usually we have a deuterium lamp. There's a liquid the input energy from the power source produce an excited deuterium molecules that dissociates into two atoms, okay, in the ground state and a photon of the radiation. So ang mangyari, okay, since meron siyang excited state, as the excited deuterium molecule relaxes, its quantized energy is distributed between the energy of the photon and the kinetic energies of the two deuterium atoms. And this can vary from what? 0 to the original energy of the excited molecule. So if you're going to look at this, na-excite siya, so the excitation of your deuterium molecule there, okay? And the energy of this radiation, which is just the difference of the what? The quantized, the difference between an excited state and a ground state, okay? And because of that, they can vary over some range. Hindi siya specific. Kasi usually kaya ka nagiging specific, let's say if you remember the Bohr model, so usually at a specific n value, let's say n equals to 2, tapos nag-ano ka ng from excited to what we call ground state, pumunta ka sa n is to 1, it gives up energy at a specific wavelength. But that is not the case for the deuterium. Kasi ang nangyayari sa deuterium, na-excite yung deuterium molecule, tapos nagdi-dissociate siya nung dalawang atom, either into a ground state and a photon of radiation. Meron pa rin siyang photon of radiation. But the difference in this one is hindi siya specific, like from one energy level to another energy level. Okay? Kapag na-excite yung deuterium, dinidistribute niya yung energy ng photon at yung kinetic energies ng dalawang deuterium atom. So parang continuous yung supply ng energy. I don't know if you still remember the Bohr model. Okay, yung explanation nila, bakit yung certain elements, they just emit a certain wavelength or you can only see them at a certain line. Like yung sodium, makikita mo yung solid na yellow. Because they excite to a certain energy level, and then when they go back to the ground state, there's a specific energy level, but not in the deuterium lamp. Nagkakaroon ng distribution ng energy ng photon at yung kinetic energies ng dalawang deuterium atom. Okay? Question? Now, kung mag-behave sila kagaya yung usual na na-excite tapos nagbabalik sa ground state, then you have a line spectra. Hindi continuous yung energy source mo. Yun yung advantage ng deuterium lamp. So, photon detector and heat detector. Ano yung difference ng dalawa aside from the wording? They're both detector. Right? So, ano yung difference ng photon kaysa doon sa heat? So maybe we go with the photon detector first. So usually, ano kaya yung nito? Anong signal yung na-produce dito? Anyone? Light? Specific. Line spectra? So, ano sa tingin nyo yung nangyayari kapag photon detector? There's collision of what? Okay, emission, okay, of electrons. So we could say specifically from a photon or photosensitive surface. So ang na-generate dito or na-produce dito ay current or voltage. And it is produced as a result of the emission of electron from a photosensitive surface upon collision with photons. So yung photons mo yung light. Now, ano naman yung heat detector? What do they absorb? And what do they produce? The word is heat. Ano yung associated sa heat? Okay? So usually if you have a heat detector, it consists of a darkened material or darkened surface that absorb infrared energy, and it produces a temperature increase. And how do you detect the temperature increase? You have a thermal inducer or transducer. And this produces what? Electrical signal. And its magnitude is, we could say, related to the temperature and the intensity of the infrared. So we could say the heat detector is an infrared device compared to the photon detector. Now let's go with words. Nadami pa yan aside from what we call the words that I put here. Spectroscope, spectrophotometer, spectrograph. And if I'm not mistaken, may lecture na nandyan, mini-mention kung ano yung iba pang word na ginagamit. Okay? So spectroscope, spectrophotometer, spectrograph. Sige nga, isa-isahin natin. First word, spectroscope. So ano meron sa spectroscope? Spectrometer. So usually when you say spectroscope, it's a device that measures the spectrum of light. And if you're going to look for specifics, dito sa spectroscope, okay, what do you usually have here in a spectroscope? Usually you have a monochromator with an eyepiece. That move along the focal point, the focal plane, the focal point. And if you're going to look at the what we call spectroscope, the angle between the incident and the dispersed beam is a function of wavelength. Where do you use the spectroscope? I just what we call mentioned to you the definition. Okay, a spectroscope device that measures the spectrum of light. So a spectroscope is used for the visual identification of the atomic emission line. Compare it to spectrograph. So anong definition ninyo sa spectrograph? Spectro pa rin pero hindi na scope. Yung spectroscope parang telescope eh. But the spectrograph, ano yung pagkakaiba niya doon sa spectroscope? So, meron ka pa rin what? Monochromator, pero meron kang film. Or photographic plate. And it's located along the focal plane for photographic recording of spectra. So, ang pagkakaiba dito, photograph, spectrograph, combination of spectro and a photograph compared dun sa isa kanina, spectroscope, combination ng spectro tsaka telescope. So what the spectrograph do is an instrument that separates incoming light by its wavelength or frequency and records the resulting spectrum in some kind of multi-channel detector like a photographic plate. So when Raman discovered that Raman phenomena, he's using the result based on the spectrograph. Okay, if you hear the story of how Raman, what we call discovered the Raman phenomena, the Raman scattering. He was so sure that he's going to win the Nobel Prize that he booked a ticket going to Sweden half a year before the event. Now, the last one that we have here is spectrophotometer. So meron pa yung spectrometer, spectrophotometer. So you have to look at the wordings. Kasi babanatan ko kayo dito sa multiple choice. So again, you have a monochromator here. But what's the difference? Meron kang detector, or we could say a photo detector, and located in its exit slit. So provision is made for removing the dispersing elements of various portion of the spectrum can be focused on the slit. So yung spectrophotometer na ginagamit natin, okay, sa UVBs, yan yung tipong ano, it measures the amount of the photons or the intensity or light of light that is absorbed after it passes through a sample solution. Yun yung spectrophotometer. Now, if you just ask spectrometer, it's a scientific instrument that separates and measures spectral components of a physical phenomena. So we could say yung spectrometer nyo is broad term. Para sa lahat. Okay? Na nag-describe yung interaction ng light with matter. Okay? Kasi sa chapter 5, what do we call MS? Ano yung meaning ng MS doon? Class. Mass spectrometry, or we could say mass spectrometer. But the question, do you use light there? You use energy, not really light. Okay? The story of what we call the mass spec is how to make the elephant fly. And I have the honor to meet John Penn before he passed away. Siya kasi yung nakakuha ng Nobel Prize, okay, because of this mass spectrometer. Okay? So I think I'll finish here and then I want you to go over them so that I want a lively interaction next meeting. So try nyo anuhin, panoorin ninyo yung video. Okay. And then what we call have a lively interaction. Para at least may meron kayo matutunan. And you can ask question also during that time. So I expect everyone saan magagamit yung fluorescent compared to UVBs and other stuff. So question. Meron pa kayong quiz sa Wednesday, di ba? So maybe I'll have the quiz. Let's see, because we will go over on Wednesday mass spec already. I'm going to email to you the problem set of the mass spec and you can start watching also the video. So maybe after we're done, I can give the quiz for chapter 5. Because if I'm not mistaken, ilang araw na lang tayo. 2 linggo na lang ba? Oh shit. 3 meeting na lang pala tayo, no? So ano yan? Every meeting may quiz? So I want you to watch the mass spectrometry. So tatapusin natin yung problem set ng 4. And then we will have, I'm going to post in the group chat the problem set for 5. And you have some a simple mass spectrogram that you need to solve. So maybe I'll ibibigay ko yung buong problem set and I'm going to let you know which one you need to solve. And then we have electrochemistry. Okay, so medyo wide yung scope ng electrochemistry, but I can just what we call simplify it. I just want you to watch the videos that you have there. And last but not the least is the radiochemical methods. So the application that we have is what we could master. So everything should be covered doon sa links na binigay ko sa inyo. So I would just say, watch them. Okay. And most likely since 3 na lang yung meeting natin, so we're going to have the quiz after that thing. Hanggang kailan lang tayo? 20 lang ba? Oh, 21 is our last day, right? Okay, so let's see. So siguro 21 mag-meet tayo. Have our group photo before your Christmas break. And then that's it. So prepare ninyo mag-meet lahat tayo sa 21 para meron tayong souvenir photo. The last batch of 137 students na tinuruan ko. Na hopefully may natutunan. So question.